Um, Hello. Um, I just wanted to make a short video about the robot that we've made for electronic and photonic components class at our university. Well, first of all, I'd like to thank all the team members that have helped build this thing. We had a lot of fun, and well, we had a lot of trouble at some points fixing some of the issues that we had with it, but we finally got it working. Well, I just wanted to show you a little bit, make a short video about it. Well, first of all, we have an Arduino here connected to an XP module. We've added a remote control function for the robot using XPs, and we've brought in a whole communications protocol that is handled by the Arduino down here. And down here we've got a PIC by microchip that will be the one controlling the motor functions and the bumpers, etc. Well, the circuitry is relatively simple. We have a small data bus, a 4-bit data bus that goes into the robot, sends like the commands such as move forward, backwards, etc. We have a sonar here to measure distance and avoid objects. We have two LDRs there to sense light and a couple of LEDs. We also have this LCD that is controlled by the PIC down there. Basically, what the PIC takes care of is the motor function and the bumpers. I mean, the PIC will run a program that always will try to avoid objects as long as they are detected by the bumpers over here. But also there is a series of commands that can be sent from the Arduino telling the robot to avoid an obstacle that is in front of it, or just to move in any direction, different kind of commands. Also, we wanted to add the feature of having a sensor, a motion sensor on the back, or proximity sensor if you will, but after we built it we realized that the reach that it had wasn't too much. It was actually very short, and it wasn't a really good idea to use it to avoid objects. See, the robot moves relatively fast compared to the frequency at which these measurements are updated. So in the end we just decided that the robot would make a sound whenever there was an object near from behind. And here I like to show you the remote that we've built. It's got an LCD and matrix keypad over there. We'll input all the commands in here to control the robot, etc. Well, now I'm going to show you. Also, I've lifted the robot with a box so it doesn't move all around, to make just this presentation a little bit easier. Okay, so I've turned it on. You can see there that the XP has entered its main function. We know because the LED is blinking. It blinks every time it runs a whole a certain routine that it's supposed to run every 2.5 seconds. Also, for the PIC to start its program, you have to press the D button that we have over there, right next to reset. Once I push that button, it's going to move forward. Well, probably it's going to try to avoid the objects that are in front of it. So I'm gonna try to move it backwards a little bit, so it doesn't stop trying to move forward all the time. With set the distance at 50 centimeters, it will try to avoid any object that it stands on its way at 50 centimeters using the sonar. Also, we had a little problem that both motors didn't run at the same speed, so the robot slowly turns. We thought of fixing that using a compass, an electronic compass, but we didn't have the time to implement this function because we have to finish this project by just the demo, etc. So when it's trying to avoid an object there's a distance of 50 centimeters, it's going to perform a relatively small turn, but it should be fine. Here is the remote control. You can see there is requesting a password. We've decided to put a password protection on it. the idea was to give the robot a theme. We thought of it as a space exploration robot, so we thought it would be a good idea, to protect your investment from, I don't know, anyone. So I'm going to press D. I hope it's not measuring a far, too near object and but it just tries to move forward. All right. Well, you can see that both wheels are moving forward. The LCD is displaying boost restore. It means that the database that it has, it's got zeros on it. It's a function that we've implemented in order to debug some of the problems that we had. I don't know if you can hear me because these motors are relatively loud, but I'll keep on. I'm gonna hope you can. So here is the remote control. All right. If I enter any sort of random password, it's going to display the number for a moment there to check that you can actually tell it right. If I confirm this wrong password, the robot, not the remote, is going to warn me with the sound. And then I have to reset in order to type a new password. The current password is 9876. Once we confirm this password, it's going to show us the version and attempt a connection and sync all the flags that both the remote and the Arduino and the robot have to have in common. Alright. Well, now it's synced. This is the main function. Alright. The robot will try to avoid any object that comes into its path. If I put my hand over there, it's going to detect the distance and avoid it. You can see there that it's trying to avoid my hand. Once my hand off, it tries to move forward again. Also, the LDRs are controlling the LEDs. The idea is the LEDs will turn on automatically when there isn't too much light in the room. Well, right now it's morning, so you can probably see it, but let me see if I can somehow cover them. Well, but I promise you that works because we've tried it multiple times. It's very simple. We've just adjusted the sensitivity. It's too high. It's got to be a really dark room for the LEDs to turn on. And also here's the proximity sensor that as you can see, when I put my hand near it, it beeps. That's fairly simple. And now with the remote, which is probably the greatest feature that we have. Here is the remote. 1 and 3 should turn the LEDs on when we are in the remote control function, which we are not right now. 2, 5, 8, 4 and 6 are the remote control themselves, forward, backwards, stop, left and right. These two buttons over here activate and deactivate and activate the remote control function, and this button over here performs a systems check. It syncs the flags, etc. This is probably the greatest feature that we have. We call it AureReport. It means that it's going to send information back to the remote control with the distance that it's measuring. Right now it's measuring 76 centimeters, which seems about right. Every time it senses less than 50, it's going to try to avoid that object. You can turn it off pressing 9, but we don't have the time to implement the option to erase the screen. So if I deactivate it, it's still going to show there the same distance. Also we are using that data package with the distance to provide a confirmation of the correct workings of the link of the RF link between the remote and the Arduino on the board and the robot itself. Now, this is the function that we've had most of the trouble on. Sometimes the robot does not seem to catch the remote control command. Once we send it, it will answer to the next order that you sent. Let's say 5. Alright, it worked. See, it stopped. 5 means stop. If I push forward, you can see it's moving forward, backwards, stops, turns to one side and turns to the other side. You can see on the screen that it says remote on, and it correctly accepted the command. Also, I can turn on and off the LEDs. I'm not sure if you can see it over there, but well, you can still activate and deactivate the auto report and request a systems check. If I now send the function to restore automatic mode, it will automatically start moving forward again and try to avoid objects that come near it using the bumpers and the sonar. I also like to comment that the bumpers are always active. Even when you're using the remote control, if it comes across an object with the bumpers, it will try to avoid it. And this is an intelligent turning. I mean, it will turn depending on which bumper. It will turn to one side or the other depending on the bumper that you've pushed. Just to see that I'm not lying, I'm going to put the remote in front of it, and you can see they're trying to avoid it. Alright, I'm going to turn the option instance back on. There we go. Well, that's pretty much it. Remote control on, control, autopilot on, and yeah, that's pretty much it. I've turned the AureRemote function off because it tends to overload the link between the remote and the robot. So it's good to have it on for a while, but sometimes it's better if you turn it off and switch these two modes in order to get the screen cleaned. Well, I'm also going to attempt a systems check when the robot is off, so you can see that it will actually tell me that there is no connection between the two of them. Also, if you can see here, the screen says boot restore again because there's been 0. So if I send this command, it will tell me that the remote is off. Hold on a moment. I'm gonna show you how it will check the link and tell me that there is no signal when the robot is off. Oh, by the way, you can see now that the LEDs are on. Seems like there's less light now in the room than it was before. Right, I'm going to turn it off over there. And there we go. Hold on. Alright, so here we go. I'm going to attempt a systems check now that the robot is off. As you can see, it's trying to connect to the robot, but obviously the robot is not answering. So it's going to show me a RAR not signal message on the screen and provide information with the latest update that it had with the flags. You can see there it enters the standard menu. You can still send commands, but you know, you are not sure. You no longer can be certain that the robot is receiving them, but still you can send them just in case that there might be some kind of problem with the systems check, and you actually need to send those commands. Well, this is the AureMars and the AureRemote, and I hope you liked it. Thanks, thank you for watching, and well, we hope to see you again.